Alright, in this video I want to mess around with some of the simulations that are available on the University of Colorado Boulder's website, phet.colorado.edu. The University of Colorado Boulder has a very large set of simulations available to help you understand how a lot of the concepts that we deal with in physics, chemistry, biology, how all these things work. The first one I want to show you here is the simulation that they have for static electricity. It's your basic balloon and sweater deal. We talked a little bit about the three ways that an object can acquire a static charge. And the first one is conduction. And conduction involves rubbing the two insulators together. Insulator number one, the balloon. Insulator number two, the sweater. And you'll notice on the sweater, we have a pretty much equal number of positive and negative charges. If we could see the charges on the balloon, it would be the same, an equal number of positive and negative charges. These are both neutral objects. When the balloon is rubbed on the sweater, you'll notice that the balloon picks up the electrons. The balloon takes the electrons away from the sweater, leaving it positively charged, and the balloon negatively charged. Friction is that process of acquiring a static charge where the insulators rub together and electrons are rubbed off of one insulator onto the other, making one object positive, the other one negative. Now, because they are charged and they are oppositely charged, they are attracted to each other. The balloon will be attracted to the sweater because they are oppositely charged objects. Induction is another way that we can acquire a static charge. In this case, now I've added a wall to it. And again, just like the sweater, it is neutrally charged, an equal number of positive and negative charges. It's kind of hard to tell the difference because they're overlapping each other. The balloon negatives are sitting on top of the red positives. Watch what happens this time when I charge my balloon, rubbing it on the sweater. Again, that is friction. As I bring this balloon closer to the wall, watch what happens to the electrons in the wall. Notice how they move away from the surface. Notice how they're not even touching. It's as the balloon gets close to the wall becomes positively charged. Negative balloon, positive wall, they are attracted to each other, and again the balloon can stick to the wall. The simulator does not have a good demonstration of conduction on it, so I'm not going to be able to show you that one with it, but I think it's a great example of how these two mechanisms anyway, the friction and the induction, work. The other simulation that I want to show you is the one for circuits in alternating and direct current. What I'm going to do is build two simple circuits, one for alternating, one for direct current, so you can see the difference between the two. My direct current system will start off with a battery. To it we shall attach a light bulb. This is my direct current system, and you can see, hopefully, that the electrons are flowing in just one direction around this circuit. It's direct current because it flows directly from this side of the battery to the other, in one direction the whole way around. Make an alternating current circuit with the same pieces. Light bulb, an AC power source this time for alternating current, and some wires. And this time around, the electrons are not making a complete circuit. They're not going from one side to the other. All they're doing is moving back and forth inside the wires, switching direction, back and forth. It's because of this that it transmits a greater distance. If I want to move electrons through the circuit, I have to have enough voltage to push the electrons all the way around. In this one, I only have to move them a little bit, back and forth. The single electron doesn't go very far. That's why we can transmit at great distances. Notice the flashing of the bulb in the alternating current. As I said in the video, a light bulb plugged into an alternating current system is turning on and off, just too fast for us to notice. This one alternates at a much lower frequency so that we can see the flashing of the bulb. It does not happen in the direct current system because those electrons are always moving. There are a lot of other simulators on this site, a lot of different types. We'll see one when we start talking about series and parallel circuits in the next video. I do strongly recommend that if you are interested in playing around with some of these, if you're interested in trying to learn them, it is phet.colorado.edu. I always find it by just searching PHET. It's always the first link that comes up. They have simulators for physics, biology, chemistry, earth science. They even have them for math. And in those, they're subdivided into even smaller units. We've got motion, sound, and waves. We have work. We have a lot of things we've talked about in here. All of these would be excellent ways of brushing up on your skills, getting yourself prepped for the EOC, and tests in the class.